Amazing. So we are here, we are live. I'm going to move into present mode. And per typical motions, I'm going to go ahead and give about 2 minutes before we kick this off formally, just to give people some time to jump in. But for those people who are joining who are very punctual on time, thank you for joining us. My name is Bo. I work in enterprise marketing here at Physna, covering all things from product marketing to customer marketing to general enablement. And I am joined by my good friend and colleague, Scott Shipley, who leads sales engineering and architecture across our enterprise side. Scott, you want to say hi?
Yeah. Good morning, good afternoon, everyone.
Good morning, good afternoon, and actually possibly good evening, which is also another space of that as we look into this global space. So we'll give it about 1 more minute here. Oh, Timothy, good morning. I'm glad you've been looking forward to it. Thank you for joining us. And actually that allows me to move my chat function over into the side and makes it a little bit more convenient for me. So thank you for doing that. All right, after, we are now going to go into go mode for this. I'm going to go ahead, I'm going to share some quick house rules as far as just how we want to approach the conversation today. We're going to keep it relatively casual and informal. What we will do is we will hold all major questions until the end. You are able to use the chat feature or the function feature during to queue up any questions that you might want. But once we get to the end of the presentation, we're going to save an ample amount of time just to do regular questions and answers for anybody that might have them. And again, just thank you for joining us. And Timothy, love the enthusiasm on your side too. What we are going to walk through today, as I go back into my other screen, is the idea of building resilience in automotive supply chains. And so for those of you who were able to join us for our data integrity webinar a couple weeks back, this is the second in series of 4 webinars that we're leading around spaces where we have seen Physna pop up and add value and create value for our customers across all aspects of their business. But the point isn't to just plug Physna the entire time. It's to take what we've learned from our customers, distill that with research that we've done on our own, and provide a series of best practice guides for how you can tackle these challenges as a business, and obviously talk through the areas where Physna can integrate and be incorporated into that process with you. The one major thing that I'll call out, and as myself and a few of my colleagues were preparing this session, we also realized that 45 minutes to unpack all things supply chain and building resilience in supply chain just isn't enough time. So expect a pretty abbreviated version of this, but afterwards, we're going to go ahead and we're going to send a series of best practices guides that are much more detailed into what you can use as an organization to align yourself throughout your business when it comes to supply chain. And so that's the one thing I want to make sure that I say. It's like, I'm not going to sit here and tell you it's like I am the say-all end-all sage of this, because there are full conferences dedicated to this topic alone. And we just want to talk through some of the things that we have seen as an organization, and so that you can take that and compare that with your own processes and the way that you approach things as well. So again, thank you so much for joining, and let's go ahead and jump right on into it. If you joined for the data integrity webinar, you know I like to start things with quotes, especially ones that are really pertinent to the conversation that we are going to have. I'm starting with one that came from the TED Talk that Elon Musk gave last week, which is the hard part isn't building the car. The hard part is bringing the car to manufacturing scale before going bankrupt. Elon was in the news quite a bit for things that didn't involve this at all. But I thought that this was a really fascinating aspect because he spoke on something that was really true and pertinent, which is building something once is relatively easy to do. Like most humans can build their own computer if they chose to do so. But building 100,000 computers requires a lot of different levels of complexity, knowledge, insights, humans with specific skills in order to make that happen. And that's really where supply chain comes into play. One thing we hear from everyone is this is kind of a Yogi Berraism, but supply chain is supply chain. It's like supply chain is everything. when we do it. It's every person, every aspect of your business that brings the product from an idea to iterative design to your customers. And that's what we really want to think through and talk about that, especially when it comes to the modeling point of view, which is where Physna is going to start to plug into that. And we're not going to belabor this point, but supply chains are impacting all businesses. And we know this to be true. If you guys are in this space, it's like, you know it to be true. The COVID pandemic shined a huge light on the fractures and the delicacy of that supply chain. And we're seeing that with factory closures that it's like are slowing down the productions of core materials. Also, it's like reduced labor supply, as that also continues to drive an impact and getting people re-ramped up and factories up to full speed. And also transportation costs are skyrocketing. There's where it's like the quote here that we pull up is it's like you're roughly looking at like 25 to 50% higher costs and actually moving things from point A to point B. That has actually, there's some really positive things that have come from that, which are, you see things in topics, and we're going to talk a little bit about this, like onshoring and additive manufacturing that have been incorporated into supply chain resilience practices that are actually bringing those supply chains closer, which are actually a lot better for not only for business, they also increase your depth of suppliers, but that also is better for the climate. It's better for, and it's cheaper for you as a business. So those are some of the positives that come from that. But again, they're all really, these are things that are stressing out the majority of business, especially when it comes to automotive manufacturers. One wild thing, and I'll share this out with you guys afterwards, was this report where companies are buying washing machines just to extract the chips that are inside of them so that they can use them. So it's like, you're going to go out and buy like a washer, and then you're going to just pull out that semiconductor that's sitting inside it because you know that you have an applicable thing for it too. That's one, very resourceful, but two, it's like, that's not the ideal place of where we want to be. One, to add a little bit of humor, this is affecting everyone except for Arizona iced tea. This is a funny, but awesome story in which you have one set of folks, bless them, who are like, look, our product is already okay. It's like, we're not going to add more cost to like the end consumer. Most of us aren't in that position of luxury. And that's why we want to spend time talking about the tactics to build more resilient supply chains. And again, this is the Cliff Notes version of this, but hopefully you'll be able to bring this back into your own practices and actually inspire more learning along the way. But what we want to focus on is we want to focus on what you as a business can control. I can't focus on the outlying like geopolitical impacts of what are going on from moving things from point A to point B, but we can focus on the people who help bring your products or who help like you build your supply chain with. We can focus on some processes you use to bring those products to market, and we can focus on the products you use to actually build your products or the technology. And we'll get to this, but this is where Physna is going to come into play. We're going to start with this 3-chain by focusing specifically on the people, because as I unpacked a lot of the information from customer conversations and dialogue, everything centered around the people that were invested in that supply chain as being the central part of what you should optimize first. And in doing so, a lot of the process aspects actually start to find their way. Optimize for the people that you have, and the processes themselves will start to feel themselves out. Now, back to the other point, we will give you a lot more deep dive information into like those processes like in the follow-up to this, but we're not going to spend a ton of time here, just strictly for the terms of like timing impact. And when we look at those people, I'm going to divide them into 2 groups just for simplicity. The first, the people who design and develop your products. And the second, the people who supply your parts or your suppliers. The people who make up your supply chain and those who design your products are you know them. It's like those are your engineers and your designers who are building 3D reference models every single day. Your supply chain leaders, which many of you are when it comes to sourcing materials that bring those models to life. And then you have your factory workers, managers, and everybody else that exists within that supply chain that makes sure that that stuff is production ready, so that you are taking the turbocharger, which Scott will actually demo this in here in a couple minutes, from a 3D CAD file to a physical object that's ready to go into an automobile assembly. Those are the people that are actually building this stuff every day. And when I walked this through with a couple of like close friends who work in supply chain, they're like, yeah, this is the ideal model. It's like you have things go from design to part sourcing materials to pure manufacturing. But the truth is like, it's not that clear. It's not that transparent because there are these functional silos that develop over the course of time that make it so that your teams are properly supported. They're intentionally built for those purposes. They also become the root cause of a lot of those supply chain breakdowns. Because if you think of the links in a chain, I'm sorry, it's like, of course I was going to make this analogy at some point, but if you think about those links in a chain, adding those distinct barriers of communication slow processes down. Things get designed twice. The surplus parts get ordered over here. They get sent to distribution center A versus center B. There's a lot of different nuances that come to it that are really small things that add up, that making sure that it's like you have the proper communications channels built in place is really important. And one thing, and this might be a hot take, I'm not going to come back and say that all silos are bad. There's a very real reason why you have them. It's just the important piece here is to making sure you have the process and communication elements aligned so that you can be successful in communicating across the board. This is going to become really important when we talk about the technology piece here in a second. And so here's the one core takeaway within this space that I would leave you with is, from everything that we do, and this seems so simple, and I understand that there are so many levels of complexity that come with this, is build collaboration into the design and procurement processes at the front of your design cycle. That's where you can start, because in doing so, you're going to minimize the downstream impacts that's going to have on the manufactured product. That's a collaborative effort that's going to come from, it's like everybody who's working on like factory floors to folks who it's like are managing the end-to-end supply line period, but also for the folks who are designing your product. It's like that element is really, really critical. And then the second piece, we're still not going to talk about Physna, is investing in technologies that help foster that collaboration. That's what people say the promise is, but it is really critically important that the people become the focus point of that, because unless you get the people piece right, the technology piece isn't going to functionally work that well for you. It's like the implementation is going to be okay, but you're not going to drive the adoption need across all of them as you go. Not quite yet. And so now the second part of this is the suppliers outside. It's like everybody, it's like if we look at that center column, it's like who are actually giving you the parts that you need? Who are you ordering the parts from that are going to make your supply chains more efficient, that are going to actually give you the tools that you need to build that turbocharger? And one thing we found that was kind of shocking was that 92% of supply chain decision makers don't, like, one, they report a direct impact from sourcing issues, but only 31% of companies have developed alternatives from their tier one suppliers. I thought about it and I'm like, what, like how does that happen? But it's a really understandable thing. It's like you build out the relationships. Those are trusted provider relationships that help you bring your products in. It's like you build the trust at that space. But what that doesn't allow you to do is build redundancies across the board. So what you see here is it's like you have in this model, it's like you would have supplier A and supplier H who are supplying most of your models, where you're not tapping into the opportunities with B, C, D, E, F, and G. And this is where when we talk about those, bringing in those practices of onshoring or looking for suppliers who are closer to you, or even bringing additive manufacturing practices in-house, that's where we're going to start to see a lot of benefit. Now, on the additive manufacturing side, we're still early in that stage. There's a lot of people that are really starting to do it because the technology is coming to a place to where it's one, financially viable to do, but also that it's accessible for more companies, and it makes sense from a cost point of view. So those are the big things. It's like the first thing in that is take some time, sit back within your own process and figure out it's like where those gaps within your own supplying system are. It's like, are you over indexing way too much like Bose bolt shop versus like Scott's washers or something like this? It's like, and sorry, Scott, you would do something way cooler than washers. I totally promise you that. But making sure that you're thinking about those things as you're going out and you're building out your like annual procurement or 5-year procurement process and plans, and you're starting to fill that stuff out. It's really, really critically important. Now we're going to focus a little bit on the technology, and this is where we're going to start to transition a bit and where Fizdin is going to come back into play. And again, structuring this intently, I said this before, really important to get the people part right from both supplier side and process side, because that's going to make sure that it's going to enable that level of adoption that you need across the board, across all of these technologies that you're going to invest in overall. And there's the technology that's been developed that your supply chains rely on. They're purpose-built products that are built and designed for a specific function. So you have AutoCAD, Solid Edge, Parametric for engineers and designers to go build 3D models from scratch. You have Anvil, Windchill, SAP, the list goes on for supply chain leaders that help them manage that end-to-end process. And then you have things like workers, managers who are using things like NetSuite, QuickBase, Fishbowl. And yes, I have put Excel here. I'm going to talk about that to really manage like in-house warehousing inventory needs. The interesting piece of this concept is, having now been within this space for the last 12 years, Excel is one of those products that's like, it's always there. It's like, it's one of the things that always pops up. It's like so many folks are managing complex systems and processes with Excel. And that's because it works. It might not be the best, but it's always going to work. So it's like, I always want to give them one, a tip of the hat, because awesome. But two, it's when we're looking at core functionality, when it comes to, it's like procuring models and making models accessible, there are other alternatives. I'll leave it at that. And this is where the siloism doesn't help. Like those functional silos that exist within your crew work because it helps make sure that it's like they have the right tooling and resources they need. When you look at things at the model and the object perspective, the silos start to break up the way that your community, the way that your technology collaborates with one another. And that's because they all are viewing that data, that rich model data, in a different way. And there's a reason for that. There's a functional purpose for that. But what happens is this is also where, when we talk to people about like, people are making duplicate designs, it's like they're ordering like excess inventory from A versus B. This is where a lot of those problems start to pop up. And this is where Physna starts to move into that space with you. And so I finally got to it. It's like where we actually are going to start talking more about Fizdin and the core functionalities of Fizdin, where it plugs into this. But what Physna does is it brings all of these technologies together by enabling collaboration at the technology level based on your 3D models. When we looked back up into slide 10, 11, 12, the focus point there was, it's like the 3D CAD design. It's like everything that we build starts as a 3D CAD design, all the way to the finished product. That becomes your referenceable material. This is where Physna really plugs in and starts to help. And it can actually leverage the power of your 3D models to increase that level of resilience at the technology level. And the reason for that is because we create this single source of truth that connects into all of these different systems so that you can look up exactly what you need when you need it. If you're a supply chain leader, that means that you're able to identify sourcing inefficiencies and recognize cost savings based on the object themselves. That's going to be less so for this giant turbocharger we have here, but that becomes really applicable when you start looking at the individual bolts that hold that turbocharger together. And those savings add up over the course of time, and being able to see where those things came from becomes really, really important. For engineers and designers, this is where it's like the reduction in design time and the reduced design inefficiencies that come from just being able to find a source model really quickly, always come back and help like speed up and accelerate that design process to help mitigate any of the other downstream impacts that could happen. And so you're designing products faster, you're centralizing around that sort of things. But then from a service tech point of view, you're now able to easily identify like parts or misplaces and things that you need as you're trying to get this thing out the door. And that can then easily relay back over into your designers and your procurement pros and saying, hey, look, we need bolt A, like where can I find it? And so this is one of the aspects of how you're going to come in and do it. And here, if you're a supply chain leader, this is where the smart procurement decisions start to really play into this. And one of the things is this idea here of what we see is it's like you see this larger brake assembly, we can see where it's like where those file locations are, where the teams assigned are, where the physical locations are, and who is supplying it. And being able to understand that it's like this comes from multiple different suppliers who are supplying multiple different aspects for this assembly, so that you as a supply chain leader now have the tools that you need to say, oh, great, I can go negotiate like a better cost for this specific like brake rotor or bolt or washer or fastener of any which way shape, and make that and add up all of those time savings across the board, strictly because you're truly identifying what this model is based on its unique geometry. There's a lot more that I could do with that, but in the course of time, and because I know that we join these things because we want to see products in action and really talk through it, I'm going to turn the screen over to Scott so that he can then walk you through the product itself, and he can show you some of the features and functions that we actually provide here. Scott, all you.
Awesome. Thanks, Bo. Well, I'm really excited to walk you all through the Physna Enterprise solution today. So I think what you're going to see is some really innovative technology that we would argue is the future in harnessing the full potential of your 3D data. So let's just start with what is Physna, right? So as Bo mentioned, Physna is a cloud-based AI software solution, and it breaks down the structure of 3D models to do certain things. Specifically, we want to do analysis on those 3D models. We want to be able to search them. We want to be able to compare them to other 3D models. We want to be able to classify those different models, and I'll walk you through how Physna helps with that. And so how we start is we take an existing model, we apply a lot of advanced mathematics and machine learning to those models to make them accessible, to make them searchable, and ultimately actionable, right? So that you can apply the learnings from that to a broad range of business use cases. Some of the areas where our technology helps is we really hear a lot from different companies we talk to that we can help reduce the time that it takes to design parts. We can help lower procurement costs, and we enable deep learning and insights across your 3D data. And honestly, from what we've seen, we haven't seen anything like it on the market. So that's why it's pretty exciting for our team to get to talk to potential customers like yourself. So let me go ahead and I'm going to share my screen here, and I'm going to start with our consumer side of the business. So there's an enterprise side and there's a consumer side. And so things.com is the consumer side. So the reason why I like to start here is because a lot of the core underpinnings of our enterprise product start here on the consumer side. And so what you'll quickly see is we have over 12.5 million models with thousands of concurrent users. And the other cool thing about just things in general is if you're into 3D printing or sharing your 3D designs, it's a pretty cool site to begin with. So normally if I wanted to search something, I could click in here and type what I want to search, but I'm going to show you a really unique way that Physna can search. So if I click on this little button here, and I go ahead and browse, I'm going to actually take a part file. So this is a solid edge part file, and I'm going to just give it to Things. And so Things is going to quickly do a search through those 12.5 million models. And what you see here is that it not only found the bearing, but then it brought up the turbocharger itself. So if I go ahead and click on the turbocharger, we'll open it up here. And so I don't have a fancy CAD machine. I could do this on a mobile device, right? No expensive CAD licenses. What's really cool is I can look at the model very similar to maybe how an engineer would look at their CAD models. I can explode it and look at the different pieces. And what you see is I actually found 2 instances of that same bearing that I gave it. And if I come over here and kind of run down through the assembly tree that makes up this turbocharger, the first thing you'll notice is that you don't see a bearing listed anywhere here. And the reason why is because the bearing is actually part of a subassembly, which is the impeller axle. So if I click on the impeller axle, sure enough, you can see, here's the actual 2 bearings that we saw. So why this is interesting is and why I like to start here is right off the bat. One, we can kind of illustrate what Physna's technology is doing, which is, in this case, I found a 3D part buried inside another 3D part, which was the bearing buried inside an impeller axle, which was then buried inside a turbocharger. And why is that so unique? Well, we did it purely based off of the unique geometry that Physna created for that bearing. right? And so what this means is I didn't need I didn't need any metadata. I didn't need, complex bill of materials, or any of the traditional things that you might do when you see products that seem like they might be similar, which is really focused around searching for shapes and then applying a bunch of metadata to that. And I'll get into this a little bit more on the enterprise side, but it's a very unique differentiating piece that I kind of wanted to focus on. So let me go ahead and just transition over to our enterprise product, and I'll do something similar. So let me go ahead, and this time I'm just gonna type in bearing here, and I'm gonna search for the bearing. So I'll go ahead, and this time, because I didn't give it the CAD file, you can see I found everything that I had named bearing in this environment that I'm searching. And so I'm going to come over here and click on this actions button. And there's an option that we have called part match. And so what this is going to do is similar to what I kind of showed you on things, is it's going to actually look through all of the different CAD models that we have in this environment and show me where we might have that bearing. So if I go ahead and click on that, it will come back with a search. And here you can see it found a couple of different turbochargers, and it also found the impeller axle. So let me go ahead and open up this turbocharger. And just like on the things environment, right, you can go and you can split things apart. You can do some different advanced features. But one of the things that I want to do is I'm going to come over here. I need to move my Zoom picture here because it's covering up part of my screen. So if I click on actions, I'm going to go ahead and click over here and show you the assembly tree. And so what you can see is with the assembly tree, you can see all the different parts that make this up. And so let me just scroll down here, and I'll just pick on this example. So here's a bolt. So let me go ahead and click on it, and I'll open up the bolt, and it's nothing fancy. It's a CAD model of a bolt. But what I'm going to be able to do is come over here and compare that bolt to the turbocharger. So if I go ahead and click on that, you'll see that I have now the two models shown here. And so if we look at here's the small bolt, and then here's the turbocharger. So we can do some unique things. I can actually, start to ask Physna some questions about my 3D models, like where have you found this bolt in this turbocharger? So I do that by clicking on the intersection, and very quickly you can see that we found every location where this bolt is. But to show that it's not just related to a simple shape search, I can actually adjust the opacity, and sure enough, I can see all 8 instances of that bolt like within the turbocharger. So that's a feature that a lot of our customers love, because they want to be able to take a part and say, can you please show me where this part might be used, right? That has all different kinds of benefits, where we often hear from engineers that they don't have a great way to search for an existing part. So let's say that an engineer was tasked with designing a new bolt. It's often faster for them just to start and design something from scratch than it is to go and try and find a bolt that could be similar or identical to what they're trying to design. And so the downside of that, and how that starts to impact supply chain in other areas, is now we have a duplicate part that we then manufacture, and we have inventory on, and we have to track through like the whole environment. So this can be one way that we work with customers to help identify what are some of those areas where we could help reduce complexity and reduce the amount of time that it takes to design. So I'm going to transition over to another really cool enterprise feature. And this came back from one of our customers who said, we want to be able, specifically in the automotive space, we've heard this as well. We want to be able to give Physna a picture, a 2D image, and have it through, advanced machine learning and training that we've done, find other, CAD models that could be that part or similar to that part. And so we call that photo to 3D. And so if you kind of just, if I set the stage for you, imagine that you're a maintenance worker and, you've gotten a call that a machine in an assembly line has gone down. And so you go out to the manufacturing plant and you you go to the machine, you find the part that's broken, but the part has been really worn, and you can't really read the part number. So what are you going to do? Well, normally what we typically see or hear from customers is that hopefully you've seen this part before and you know what it is, so that you can go back to the right teams and look for the part in inventory or order it from a supplier, depending on what the use case is. If you don't have that knowledge, hopefully you can phone a friend, another coworker or someone that has seen this before. But what if you could just take a picture of that part, right, and give it to Physna and see what Physna can do? So that's what I'm going to kind of walk you through, right? We've gone through and we have this ability to be able to give Physna a bunch of models and then train them to be able to have Physna recognize all aspects of it, so that I can give it a picture. So for this example, here's a picture, and I'm actually going to try and trick Physna a little bit. So you can see this is actually a common part that you could get from a supplier, specifically in this case it's Festo, but it's one of their stopper cylinders. And so the part was kind of oily. You can't really read the part number on it. So just to make sure we're not doing any kind of trickery with reading metadata or anything like that. But I've given it this picture. I put it in a bag, put it on a dark table where it's a little bit harder for, sometimes algorithms to figure out what you're looking at. So that's what I'm going to hand to Physna. So let me go ahead and flip over. I'm going to click on classify image. And from there, I can actually go and select that part. I'm going to go ahead and open it. And now Physna, what it's done is it's come back and it's telling me, hey, based off of this image and based off of models that you've trained, I think that there could be aspects of this that could be this product. Now, I know, just because I know this part, that this is actually the casing for that. This is the filter that goes into it. Some of these other components are actually part of an assembly. Call it a super assembly or parent assembly that this stopper cylinder sits in. But here you can see, even with that kind of complex model, it went through and found it. So let's go ahead and open this part. And sure enough, like if I spin around and expand it out, you can see here's the filter. Here's the actual stopper that goes inside the casing. So we have the different piece. So awesome. Physna helped me find the replacement part that I'm looking for. Let's go ahead and click on the metadata field and see where we can actually get this. So this metadata can come from your PLM environment. It could come from ERP. There's a number of different ways through the Physna base connector that we can actually synchronize this information specific to your CAD models to really apply context, specific to your company and your CAD models to give you some enhanced functionality. So in this case, I have a stock location for this. Let's call it R54. I can see the cost of it and who the supplier was. In this case, all fictitious information, but you could imagine if it was, real data. Unfortunately, you can see I have a quantity of 0. So this does not help me since I need to get this machine back up and running. So what can we do? Well, let me come over here to another feature, which we have, which is called, our match feature. So I'm just going to paste in here like the name of the part and go ahead and click on a search. And so what's going to happen is Physna is searching for, it's just a simple text search. It's going to find everything that aligns with, that has that part in its name. So here I can see the exact part that I'm looking for. So I'm going to go ahead and click on find matches. Now what this is going to do is it's matching purely based off of geometry. So it's going to look for I'm going to give it a threshold of 80%. So any part that is 80% or greater. So if it's 100%, it's a complete geometrical match of the part. So let me just go ahead and click on find matches. So you can see that Physna came back and it found 18 results. And it tells me here, you can see what the percentage of match is. So I'm going to show you this compare feature. If I come down I'll find a part that's maybe like not 100%. So here's one that is 89.04% of a match. I'm going to go ahead and click on compare. And what you'll see is we open up a comparison viewer, and we've highlighted in red what is different about this model. So if I, again, adjust the opacity, I can see, okay, certainly like I gave it the casing, and Physna, purely based off of the geometry and what we do, found the two other components that weren't there. So let me go ahead and kind of walk you through another piece, which is starting to look at the metadata. So I have the same part pulled up. Let me go ahead and click on the metadata field. We already had looked at this before. I want to show you a different way that we can kind of look at some similar information. So in this case, I have an assembly tree. So I'm going to click on the assembly tree, and I can see the two different components. Now I know from looking at the part that I put into the bag, it's actually the casing that's the piece. And since I don't have the full assembly and I need to get the machine back up and running, I'm going to actually open up this model up so we can kind of look at it. So let me go ahead and open that up here. I'm going to click on the metadata field, and sure enough, we can see that we have 3 of these in stock. So I can go ahead and get that replacement part and get the machine back up and running. So this is an example that I put together, but it's based off of real customer experiences that they've come to us with and said, hey, we'd like to use Physna for some of these things. And I want to transition over into the last area that I'm going to show you, which is really our classification feature. And so one of the cool things about Physna is we develop in a purely agile way. So everything's done in 2-week sprints. This gives our customers the ability to give us real-time feedback about what do they like about the product, what are some of the enhancements that they would love to see. So this next feature is one that we had a customer come back to us and say, hey, I've got a situation where I have millions and millions of parts, and I need to be able to like catalog these parts. But what they had found is that over the years of trying to catalog, they couldn't trust the metadata. And so when they were walking us through, their PLM, there was actually sections of it that was highlighted in red, and it was like, do not trust the data. And so I was like, why do you have that listed there? And they said, well, it's because some of the information that we found that was put in there around the metadata fields and the attributes are incorrect. So they came back to us and said, if you could give us some sort of feature that would allow us to give you our models and then have Physna kind of group those models and leverage some of the goodness that we provide, what could we do with that data? So that's what I kind of want to show you. So we gave Physna about 1,600 different models, and so these were common parts, right, that you could find at any big box hardware store, or even from a number of other suppliers. And so what did Physna do? Well, we gave these 1,600 models to it, and Physna automatically created groups based off of geometry and said, I think these types of models are these things. So you can see I have threaded nuts in this one. I'll click on another group and it'll run through and kind of come up and show us. But the idea behind it is that it's created a bunch of different groups, based off of what it sees. So I could open up one of these models because that picture was just a little bit small. So it's going to come up here and I can see, okay, this was a threaded hex bolt. So cool. Let me walk you through some of the things that we can do. So if I click on this drop down, we then told Physna, go ahead and classify some of these different things. So I have, based off of these groups, we created classifications, and then we went in and said, let's go ahead and confirm that for sure these are threaded nuts in this case. Or if I click on self-leveling legs, we'll bring that up. And so you can see we have self-leveling legs that we've confirmed. Now we can do something very unique with Physna where I can say, based off of all of these other groups and where we have models that are unclassified or no one has gone in and confirmed that this is what it is, we can click on this predictions tab. And what happens is Physna runs through all those unclassified models, and it's going to come back with a certain confidence level and say, hey, based off of what you've given me, I think these are also self-leveling legs. And you notice they're different sizes, but we can tell they're self-leveling legs, you know, as humans. Why that's important is because this is a little bit different than a true geometric match, because the reality is if I compare this self-leveling leg to this one, their geometry is going to be very different. But I know that they're self-leveling legs and I need them to be kind of classified that way for the catalog. So I can go ahead and click on these 3 legs and I can, you know, say, go ahead and classify these. And what happens is Physna will go back and it will add those into the self-leveling legs group. And then our machine learning algorithms learn and get smarter and smarter the more you classify. Now you can go through and actually preemptively classify things based off of metadata to really speed up the whole training process, which is pretty cool. I'll show you another example here of hand wheels. So if I click on that and bring up the hand wheels, and then I'll go ahead and click on predictions. What's going to happen is you can see I have all these different types of hand wheels, and some have 3 handles inside, some have 2, some have 4. And so what Physna is telling me is, hey, based off of, you know, this percentage confidence level that you gave me, I haven't found anything. Why don't you go ahead and lower the confidence level? So let me just slide that down, and now it's going to rerun its predictions, and then it's come back with, okay, I think these are hand wheels, right? So I can go ahead and say, yep, I can look at that. They're definitely hand wheels. And the more that you do this, the smarter Physna gets, and it's pretty cool. So that's kind of where I wanted to end. So let me just recap kind of what we saw. So based off of, you know, 3D models, geometric fingerprints that we create, that Physna creates, you know, that DNA, or what we call PNA, we were able to find a bearing located within an impeller axle assembly, which was then located within a turbocharger, and we were able to compare that right, those 3D parts to a larger assembly and find all the locations, you know, with the bolt specifically where that bolt existed within the turbocharger. We looked at some of the photo to 3D functionality that we have, and leveraging, you know, attributes and the assembly tree information, we found the exact matching part that we needed to get the broken part on the machine on the manufacturing floor back up and running. We saw how Physna can actually find duplicate parts that are 100% identical all the way down to not identical, and how we could use that kind of information to search for existing 3D models, you know, to help with use cases like I mentioned before, right, for around reuse and finding duplicates and reducing complexity, et cetera. And finally, we just looked at, you know, the classification piece. So how can we take, you know, large amounts of parts and CAD data, have Physna kind of create buckets and groups for those, and then really start to go through and leverage, you know, our machine learning algorithms to start to predict where parts could be. So I'll stop there. Bo, I'll hand it back over. I think we can go through Q&A. Might be a good next step. And I think your mute is on.
There we go. Scott, thanks again for that demo, and really appreciate you taking the time to walk us through it. One of the big parts that as I watched through that, and we think back to the conversations that we've had, the conversations that we talk about with folks, and if I'm in a supply chain position, the main thing that always comes to mind is like visibility. And when we start looking at visibility based on model, you then get a really clear line of sight into your entire supply chain process from a product development point of view. And that's what we were getting back to earlier when we talked through everything starts as a 3D CAD file or a drawing of some sort that you were going to then go and bring to life. Everything you build optimizes to bring that thing to life, and then Physna itself as a technology helps you access that and make it actionable across all of the different aspects of your life cycle. And so Scott, again, thank you so much for taking the time out of your day to be able to provide us with that demo. I want to pause for a second and see if there are any questions from the field. It's like you can feel free to go into the Q&A and you can ask them. You can also ask them directly into the chat bot if there are any questions, but we are also running a time. It's like we actually did take up the full 45 minutes. And so I'll pause here to see if there are any questions from anyone within the field. Timothy Archer, I'm going to go ahead and click allow you to talk and you can ask a question.
Hi, can you hear me?
We can hear you. Go ahead.
Oh, great. Thank you. I don't have so much questions this morning as just an interest in learning more about this software on any other opportunity that comes up in the future. And I had invited a friend of mine, Sean C. Melanson. He's here on LinkedIn, and his initials happen to be SCM, and he is all about supply chain management. And
Yeah.
I hope the next time that there's an event like this, he's able to attend with us. I also have quite a large folder of connections inside the automotive industry, and of course, it's your SCM is probably as important there as anywhere else that I can imagine.
Yeah.
So with regard to looking to the near future and putting together an automotive manufacturing concern, I'd like to stay closely connected with you folks and learn more about this software and what it has to offer.
Yeah, Timothy, please do. And for your colleague who wasn't able to attend, I mentioned at the beginning of this that this is a part of a 4-part series. And so what the next one that's on the calendar is more so focused on like sustainable manufacturing practices, but supply chain is at the heart of that too. So once that pops up, it's like, take a look, we're going to post it, we'll promote it via LinkedIn. Feel free to share it. And then also feel free to reach out to any of us too, just to connect and we can talk more about it too.
Fantastic. Thank you very much for the presentation this morning. It's been great.
Thank you, Timothy.
So it looks like there's 2 other questions. Can we share the presentation? Yes, we can. I think
yes, absolutely.
We'll be able to do that. And then it looks like Jay asked a question around, does the software work for electrical components? Yes, it does. I have a couple of customers who use that exact feature. Now, the caveat that I'll tell you is, I'll just use a simple example of an iPhone, right? If I have 2 identical iPhones that have different storage memory amounts in them, obviously from a geometric search perspective, they're going to show as 100% the same. So this is where we also need to leverage the metadata for some electrical components. I have a customer that has compressors and they run at different voltages, right? So when they do searches for, hey, could you find other compressors that are like these, but also overlay the attributes so that I have context to be able to apply to it, we can definitely do that.
Great. And with that, we're actually a couple minutes over time, but I think, again, we'll just go ahead and close it out and say, like, heartfelt thank you for spending some time with us to talk about this when it comes to supply chain, when it comes to technology and its impacts to it, and in Physna itself and the technology at hand. Following up that final question, yes, you will be getting a recording of this. We will also send over some of the documentations that we've written down as well, so that you can reference that. And as always, if you have any questions or further questions or want to go deeper, we'll also send out a Calendly link so that you can schedule time to talk and meet with us. And we can talk more about your specific and unique use cases that you have as they pop up. With that, we'll call it a day, and we'll say thank you so much for everyone for joining, and have a great rest of your afternoon. Thank you.